Elon Musk has become a big, but rather an important name in the space industry now, and has shocked the world of space with something insanely exciting. It may seem like Elon Musk and SpaceX have achieved almost everything in the space industry, but things are just getting started. Elon Musk never misses an opportunity to leave the world flabbergasted with his plans, and this time, both Elon and SpaceX are working on something that's completely astonishing. Yes, you've got it right. SpaceX's insane new engines. It's been a while now that SpaceX is paving its path in space industry for quite a long time, and with their ambitions and plans to revolutionize space travel and colonize Mars, it seems like the company has a lot on its plate, and for Elon Musk and SpaceX, not the sky, but beyond the sky is actually the limit. The latest invention that the company has made in their new engines is huge, and according to SpaceX, these engines are way better, bigger, and more powerful than the ones they've made before. But what exactly is inspiring about these engines, and how are these different from the ones which have been made previously by SpaceX? How will these new engines of SpaceX impact the space industry? And most importantly, will these new space engines be able to colonize our near planet Mars? If you're keen to know what will happen next from Elon Musk and SpaceX from these new space engines, then join us on this journey, as we're about to dig into the details that you don't want to miss. Elon Musk seemed to be rather pleased with his firm SpaceX's latest rocket engines. Musk unveiled a batch of the new Raptor 2 engines this week at SpaceX's Starbase plant in Texas, where they will be deployed on the company's Starship mega rocket's first orbital launch later this year. On Tuesday, Musk wrote about these engines in a tweet on Twitter, claiming that Raptor 2 rocket engines, which are located at Starbase, each are capable of delivering over 500,000 pounds. That's 230 tons of thrust. Musk's photos seem to show over 12 of the new rocket engines. To be clear, Elon Musk did not invent a race of demonic soldiers that scream exterminate as they conquer the globe. The Raptor 2 engine will power SpaceX's Starship launches and huge super heavy boosters. These new engines, like SpaceX's old Merlin engines on Falcon 9 rockets, are intended to be reusable, just like the Starship and super heavy spacecraft. The SpaceX Raptor engine is claimed to be one of the most powerful engines that have ever been created in space history. In recent months, SpaceX has switched between Raptor V1, which was used on Starhopper, SN5, SN6, SN8, SN9, SN10, and SN11, and Raptor V1.5, which was used on SN15, S20, and B4. Raptor 2, the new version of the Raptor engine, includes numerous reliability and performance enhancements. But what exactly has SpaceX changed in its Raptor 2 engines, and why are these changes intended to bring good for the company? Before we jump into those details, let's first understand how a Raptor engine works in a spacecraft. The Raptor engine is a full flow stage combustion cycle engine that uses super-chilled oxygen in liquid state and supercooled liquid methane to power SpaceX's contemporary spaceship, known as Starship. The Raptor engine takes advantage of the very beneficial combustion cycle, which increases the impulse produced by a given amount of fuel. Additionally, all SpaceX's previous engines were using kerosene as a primary source of engine fuel. But now, with the use of methane, it's considered to be a much cleaner source of energy as it causes less harm and produces almost zero pollution. Which is again an advancement that has been made in these new Raptor 2 engines. The initial phase of Starship, known as Super Heavy, will have 33 Raptor engines, 20 non-gimballing Raptor turbines in the exterior ring, 10 gimballing engines in the middle ring, and 3 gimballing center engines in the innermost ring. This number is projected to fall in the future as SpaceX improves Raptor. Starship's next phase contains 6 engines in total that include 3 vacuum-optimized non-gimballing engines and 3 sea-level gimballing engines. Elon Musk, the CEO of SpaceX, has stated that 3 more vacuum-optimized engines will be added after the ship's length is increased. So how does Raptor 2 actually stand out from Raptor 1? Well, the answer to that question is right here. Raptor 2 features a more simplified layout than SpaceX's first Raptor, with less detailed tubing and piping lines. If we talk about the main advancements that have been made in Raptor 2, and as compared to Raptor 1, Raptor 2 appears to be a kind of rocket engine in which a considerable amount of plumbing and sensors have been removed, transforming the engine from a Christmas tree aspect to a much simpler look. While SpaceX was discovering how to regulate the engine on the original Raptor, a large number of development sensors were required, allowing them to monitor pressure and temperature throughout Raptor's plumbing systems. Furthermore, many valves were combined into valve plates, further simplifying plumbing. SpaceX has made these new engines more flame and heat resistant by removing a substantial portion of these elements, which counts an important milestone towards SpaceX's aim of removing all engine concealing from the booster, which would reduce the booster's mass by 6 tons. This illustrates Musk's "the best part is no part" philosophy. Another modification made to Raptor 2 to reduce engine bulk is the elimination of the flame igniters in the primary combustion area. Instead of depending on duplicate flame igniters, the well-mixed oxygen gas and chilled methane gas are hypergolic in the primary combustion chamber due to their elevated temperature and pressure. Raptor 2 also features fewer holes than the initial Raptor models. These holes, which are known as flanges, are useful for prototyping when parts must be switched, but they add mass and pressure losses throughout the engine. SpaceX has been able to remove several flanges on the engine now that the design is more stable, and they hope to remove all flanges on Raptor 2.5, which will raise thrust to 250 tons and debut on Rocket 12. The most significant changes was the expansion of the throat, which allowed more propellant to pass into the engine and increase thrust. This implies that if the expansion ratio is high, the nozzle has to do more work, resulting in the transformation of high pressure to high velocity, which eventually increases the engine-specific impulse. Now you might be thinking if the mass and the size of the engine remain to be the same. Well, that case is a little different. Raptor 2 is considerably lighter than Raptor 1, with Raptor 1 weighing 2,000 kilograms. The weight of Raptor 2 is around 1,600 kilograms, which makes it much lighter than the former version of the engine. But both of these versions feature the same nozzle escape diameter, and the remaining portion of the engine is nearly identical. The main combustion chamber pressure of Raptor 2 is an incredible 300 bar, which is more than 50 bar from Raptor 1, and this is the largest MCC pressure of any rocket engine ever. The previous high MCC pressure mark was set by Russian RD-180, which operates at 267 bar pressure. Raptor 2 has acquired tremendous thrust as a result of the wider throat and greater chamber pressure. Raptor 1 delivered 185 tons of thrust, while Raptor 2 produced 230 tons of thrust. The only disadvantage of widening the throat is a 1% drop in ISP, which is usually called the specific impulse. Raptor 1 has around 330 seconds of ISP, whereas Raptor 2 has 327 seconds. Another advantage that Raptor poses is the presence of the oxidizers in the engine, which can utilize the oxygen of the Earth's atmosphere and make it more efficient than it already is. So now, what are the future goals of SpaceX with Raptor 2, and what are they planning to do next? Musk's major target is for Raptor's cost per ton of thrust to be less than $1,000, which means a Raptor will require $250,000 to construct. With this goal in mind, it's obvious that SpaceX have aims to make these engines easier to build with less costs and less 3D printing. Raptor 2 is expected to boost up Raptor's thrust to 250 tons with an MCC pressure of 330 bar. Furthermore, SpaceX is trying to get rid of all throat film cooling from the engine. SpaceX could accomplish this through a variety of means. In general, it's clear that Raptor is still in its early stages. The engine, like the Merlin engine, is going to grow as SpaceX launches more, produces more, and examines more. So what are your views related to the SpaceX journey and its new mission of producing much more efficient engines like Raptor 2? Share with us in the comments below. And if you enjoyed this video, show us some love by hitting that like button and leaving a comment down below. Also, if you're a fan of space and want to stay updated with more of the latest space news, check out our other videos here that we have lined up for you. You'll enjoy watching them too.